Thank you for joining me and welcome to our section, Prepare Data in Power BI. In this section, we're discussing critical tasks in the data analyst process. In order to get our desired result of fast and accurate reports and dashboards to tell our organization's compelling story, we will cover how to get data or extract it in Power BI and how to clean and transform or shape data in Power BI. First, let's talk about how to get data in Power BI. As a data analyst, you are on a journey. Think about all the data that is being generated each day that is available in your organization, from transactional data in the transactional database to telemetry data from services you use to signals you get from different areas like social media. Businesses of today collect and store massive amount of data, yet businesses continue to struggle to use the data in a meaningful and productive way, which impacts their ability to act. The faster a business can make decisions precisely, the more competitive they will be and the better competitive advantage they will have. The key to unlocking all this data is being able to tell a story with it and via compelling and insightful reports. The critical question you need to answer right now is, where is your data? Is it in SQL, Excel, Access, SharePoint, OneDrive for Business, Azure, Microsoft Fabric's OneLake, or some other location? Usually it's in a data silo somewhere. Next, check to see if Power BI has a connector to it. There are many connectors included in Power BI that can connect to many of the popular software you might be using now. Now let's focus on Microsoft Fabric, which the Power BI service is a part of. Here you can use Microsoft Fabric, a SaaS or software as a service to do the ETL, extraction, transformation, and loading, or even streaming data processes. Microsoft Fabric has no architecture to set up, manage, or scale. You can use it to create a lakehouse if you need to support all types of data, structured, semi-structured, or non-structured data, or create a warehouse if you have only structured data. For streaming data, you can create a custom database. To start, simply create a workspace in Microsoft Fabric, enabled 365 tenant, and create a new lakehouse or warehouse or CustoDB by giving it a name and load the data you'd like to use by ingesting it with Dataflow Gen 2, pipelines, or even a Spark notebook. It loads into a single repository called OneLake, which is built on Azure Data Lake Gen 2 storage, which is hierarchical. All the services here can automatically access the data in OneLake with no configuration needed. OneLake helps to reduce all the data silos that your company might be using, providing data security and compliance. This is a serverless compute architecture that Microsoft manages and keeps up to date. You can use Copilot also here throughout Microsoft Fabric, like everywhere in Microsoft 365, Azure, Windows, Edge, and more. All your data professionals, data scientists, data engineers, data warehouse people, data and real-time analysts can collaborate on data in OneLake, effectively removing your data silos. This diagram here really drives home the need for OneLake to eliminate your data silos. Notice how typical it is for our organizations to have data in SQL, SharePoint, Excel, Cosmos DB, Azure Analysis Server, and more. Imagine if we had all of your data in one location in OneLake for all of your data and business professionals to use with no duplication or movement of data necessary. It would be fast, secure, compliant, and easy to make changes in one location that would be reflected wherever the data is used. Without Microsoft's OneLake, right now, we need to identify where our data resides and make certain it's one of the 190 plus data sources Power BI can connect to. Then you would have to import the data into the PBIX or Power BI file, or leave the data where it's at using direct query. If it's a ton of data with a lot of transformations that have to be done, it might be more efficient to set up the ETL or ELT process we mentioned earlier, the extraction, transformation, and loading process. And you can do this using Microsoft Fabric's data pipelines for extraction, Dataflow Gen 2 for transformations, with over 300 transformations available, and then load it into a lakehouse with any type of data or a warehouse for structured data. The other option for ETL is to do it all in Power BI, which is what we're going to do throughout this course. We will transform, model, and then create a denormalized star schema from that model, add calculations, and then create our reports. Power BI offers over 190 connectors to a wide variety of data sources. There are some of the most common listed here. Certain connectors have different initial configurations, but they all connect to data and allow you to turn it into meaningful insights. First, we see the Get Data dialog box with files selected. Notice the .csv and Excel files listed here, as well as a folder and more options to choose from. Here is the list of some of the database connectors available too. And here is a list of our Power Platform connectors. And of course, we have connectors to Azure's common services listed here. Lastly, let's see the online services and some of the top connectors that we can connect to. Power BI Desktop allows you to get data from many types of files. One of the possible file formats is a flat file. A flat file is a type of file that has only one data table and every row of the data is in the same structure. The file does not contain hierarchies. Likely you're familiar with the most common types of flat files, which are the comma-separated values here, the delimited text file or the TXT files, and wider width files also. Let's consider two, Excel and the XLS file in an Excel workbook. The best practice is to use OneLake or OneDrive for Business or SharePoint TeamSite to store your files to keep your semantic model, reports, and dashboards in Power BI in sync. You can also change the location of a source file for a data source if the file storage location changes by changing the file path, but make sure that you reconnect to the same folder structure, as it will cause the model to break. To connect to the data file, first determine the location of the file you'd like to use and then store it in OneLake, OneDrive for Business, or SharePoint, for example. Next, on the Home tab, select Get Data and then select the option that you require, such as TXT, CSV, or XML, or Excel, for example. Notice you can also access Excel through the Excel icon on the ribbon. Then select File to import into Power BI. Next, you will see the Navigator. Select the checkbox next to your file on the left, and it will give you a preview of what's inside of it on the right. You can select Load to automatically load your data into the Power BI model, or Transform Data, which launches the Power Query Editor. Use it to review, clean, transform, or shape data before loading it into the Power BI model. Usually we transform data first in the Power Query Editor and then load data into the Power BI desktop model. If your organization uses a relational database to record its sales transactions, you can use Power BI Desktop to establish a connection to your organization's relational database, rather than getting data from individual flat files. Connecting Power BI to your database will help you to monitor the progress of your business and identify trends, so you can forecast sales figures, plan budgets, and set performance indicators and targets. Power BI Desktop can connect to many relational databases that are either in the cloud or on-prem. However, to connect to a relational database on-prem, you will need to install a data gateway. More on the data gateway later in our course. To connect to the relational data, use Get Data in the Power BI Desktop and select the applicable option for your relational database, in this case, SQL Server. You will need to connect to your SQL Server by name and optionally list the database too that you'd like to connect to. You can select to import the data into the Power BI PBIX file, which will increase your model. Or you can use Direct Query and keep the data where it's at. Import is the default. It runs very fast because the imported data is put into memory for very fast performance. However, choosing import depends on your Power BI subscription as to how big of a model it can hold. You can use a SQL view, preferably, to import your data and include filters by reducing the number of columns and a where clause to reduce the number of records you are importing in. Import in only the data you need for better performance. Here are a few of the different types of storage modes you can choose when connecting to data sources. The import mode allows you to create a local Power BI copy of your semantic model from your data source. Importing the semantic model is the preferred method and supports all transformations, unlike Direct Query. Import supports scheduling a semantic model refresh, which we'll talk about a little bit later, and is the best choice for reports that can tolerate 30 minutes or more before a refresh. On the other hand, Direct Query creates a direct connection to the data source, ensuring your data is not cached and that you're always viewing the most up-to-date data. However, it is dependent on the data source and typically only available for relational databases, and the performance of the report and database are directly correlated. It is used when there's a lot of data that can't be pulled into the Power BI desktop due to license restrictions with your subscription. It is also used for near real-time access of frequently changing data. With Direct Query, you leave the data at the source and only the schema is imported, so you have limited modeling capabilities and transformation features available in the Power Query editor. However, we also have other options here. Dual or composite is also available. It allows Power BI to identify some of the data to be directly imported and other data that will remain at the source and queried. The best option here, though, is Direct Lake. Direct Lake is like Direct Query for Microsoft Fabric's OneLake. It is a central location to store all your organization's data to be used by all data professionals to get rid of the data silos and to have one single source of data truth for your organization. It's a great option if your data is in OneLake, and it runs very fast. While importing data into Power BI, you may encounter some of these common errors. Query timeout, which usually reflects hardware resources being constrained by concurrent users using the same data. It can lead to a timeout, which gives you an expired error message, which usually indicates that you've pulled too much data according to the database's policies. The best way to handle this error is to try the query at another time, or better yet, pull less data at a time and then append it afterwards. You can even enlist the help of the DBA if this error occurs a lot. Another common error message Power BI throws is that it could not find the file. Data sources may change locations from development into production, and even permissions may have changed too. It is best to store data sources like .csv or .txt or .xls in your organization's OneLake or in OneDrive for Business, or even in SharePoint if possible. To fix this error, simply change the source settings in the Power BI desktop. When a data type error occurs, the field usually displays blanks. This is because of an error in interpreting the data type by Power BI. Resolving this error is unique to the data source. However, in the Power Query Editor, you can change the data type to reflect the data in the field. This list isn't exhaustive, but shows some common errors encountered. Now I'll do a demo on how to get data in Power BI Desktop. Now I'm currently in the Power BI Desktop, and I opened up one of our lab files, Sales Analysis. And as I'm looking at it, you can see that I'm currently in the Report view here and on the Overview tab. And what I'd like to do is take a look at my report the way it is right now. You can see I have the filters pane on that I can roll in to get a little bit more real estate here. Same thing with the visualizations, and then the data pane will show me the current tables that I have currently loaded in. But I'm going to go look at my model view for a moment here. And again, I'm going to roll some of this in just so I have a little bit more space. You can see there's a data pane here also. And I'm going to make this fit the screen to start us off. And you can currently see some of the tables that I have. You can see the relationships that are there. We will go in more depth into relationships coming up. But as we look at this, I think there's a few things that I'd like to add to it for our report. So I'm going to go up to the top, and I have an option here to get data. I'm going to choose that. There's a lot of data sources. About 190 data sources that Power BI can pull in. And the one I'm going to choose is just the one right here, Excel Workbook. I could have gotten it off the ribbon too because it's at the top there. But I'll choose the Excel Workbook. And I have a number of lab files that I've downloaded. And I'm going to look at the product cost table right now. So that will open up my product cost table. And from right here in the Navigator, I can select the box next to it so that we can see what it looks like. And it actually looks pretty good. There's about 3 fields in here: SKU, product, product cost, and a number of records that you can see. And then down below, I have a number of options. One is load. That will take this table spreadsheet that we have here in Excel, and it will load it directly into Power BI Desktop and into the model view. It'll also add the table, of course, to the data pane, so I can use it there. That's not a bad option, taking a copy of it and pulling it in. That is actually the preferred way to work with this file, or really how to work with Power BI is to do a load, which will import it in, and it will compress it, and it will put it into cache, so it runs very, very fast. That's a good option. The other option that I can do is I can go in and transform the data. And if I transform the data, what happens there is it opens up the Power Query Editor and allows me to go in and scrub or shape or transform my data, clean my data. We'll talk a little bit more about that coming up too. So it just depends on what state I find this data currently in, on whether I want to just load it right away or whether I would like to put it into Power Query Editor and scrub it up, and then ultimately load it into the Power BI file, the PBIX file in our desktop. So right now I'm just going to load it, and when I do that, it takes just a moment, and you can see it's loading, and we'll notice that it's been added to our data model here. It doesn't have any relationships right now, and we'd have to find fields in common with the tables that we have here to set up relationships or make new fields if we needed to do that. If I go out to data, you can see that the table is there also. And if I expand that, you can see some of the fields, the same ones we saw from Excel. If I go into the table view, you can see the same table there. So you can see it in a number of views, as you can tell from here. So plenty of places to work with it. So we have Excel pulled in, but I also want to pull in from SQL. So I have a SQL Server on this computer that I'm going to go ahead and use, and I'm going to pick up the name of that SQL Server by copying in that server name there. Then what I'm going to do is I'm going to go and get some data. Now notice I have SQL right here on the ribbon. But I can also go in to get data and pick it from the list here as another option. And when I do that, I'm going to paste in the name of the server here. And there you have the option to do an import. So this is one way, import it, take a copy of it, pull it into our Power BI file here, the PBIX file, the Power BI desktop. And it'll, like I said, it'll compress it and it will throw it into cache and it will make it run very fast. So our queries will run very efficiently and fast off of that. But if I have a ton of data, one of the other options I can select here is Direct Query, where what I would do is I would leave the data in SQL. Now, this is very helpful, especially if it's a ton of data. And what I mean by a ton of data is you have to take a look at your license that you have for Power BI. So do I have the Power BI Pro license, or do I have the premium license or premium capacity? What license do I have? That will dictate how big your model can be here in Power BI. So if I have to go beyond the model size, and I know for the Pro license it's 1 gig, if I have to go above that, I'm going to not be able to do that because of my license. I'm going to want to keep it at the data source. So if I do Direct Query, I'm going to have Power BI query that data source, SQL in this case. And especially when I take this report or make a dashboard out of it, and I have it loaded in the PBI, the Power BI service in Fabric and M365, I'm going to have to create a data gateway to get to it if my SQL Server is on-prem. So when we do Direct Query, we keep the data at the data source, and then we query it, and so we will need a gateway in some cases if it's on-prem. We're going to need a VPN to get connected from on-prem to our M365. And then you'll also note that this is an option that if you decide to use, you are not going to necessarily have all the same transformation capabilities in the Power Query editor that you would normally have, simply because we don't have a copy of the data. We're using it and querying it from where it's at, in this case on the SQL Server or relational databases where it's commonly used. So I can go that route. It'll also give us near real-time capabilities, especially if our data changes on a frequent basis. So this could be a good option if we need to use it, but we have to remember the caveats. The other thing I can do is I can go into advanced options here, and I can write in a SQL statement to query that data source if I wanted to go that route. Maybe I have a view that's been created on that SQL Server that I want to call from here, or maybe I just want to write a SQL statement that does a select with a where clause. So the select would be to narrow the number of fields that we want to extract, and then the where clause would be to narrow or filter out the number of records we want to work with. The preferred way of doing this would be, of course, doing it through a view. So if I have that, that would be great, but if I don't have to work with it either here. So it's just something to think about. So right now I'm going to go ahead and do an import. It's going to try to see if it can pick up some of the relationships if it can. I'm going to click OK to this, and then when I do that, it's going to take it a moment, and it'll open up the navigator. So it's showing me my SQL Server, and I'm going to use the AdventureWorks DW 2022 option here. And what I'm going to do is I'm going to go in and I'm going to select my Fact Internet Sales table. I want to pick a table that is a fact table. The fact table will have our numbers that we want to crunch. So we'll see fields in there that will show numbers, and we can see part of the fields through here. So numbers I might want to crunch might be something like our unit price, order quantity, unit price discount percentage, discount amount. There's a bunch of them in here, total product cost, sales amount, but there's also a lot of foreign keys, product key, order date key, due date key, ship date key, customer key, and more, because the fact table has relationships with our dimension tables. So I don't know all the tables. I know there's a product table and a date table and a customer table, but there's probably others. So I'm going to click on Select Related Tables, and when I do that, I can pull all these tables in if I'd like to, but I'm going to take off that Internet Sales table there, Internet Sales Reason table. I'm also going to take off the DIM Promotion table and our DIM Currency table also. And then you can see that there's views that if we know what they do, we can pull these in too. But I'm going to pick these tables right here to load. So again, if I wanted to, I could choose Transform Data, and that would take me into the Power Query Editor where I can scrub this up if I need to. But coming from SQL, it should be pretty good to go. And then you can see the tables that we bring in here. And it may or may not detect the relationships, especially if we have a little bit of an issue with some of the tables having the same name to what's currently in here. But it usually should pull them in if it can. So what I'm going to do is I'm going to find that fact internet sales table, and I'm going to move these tables around just a little bit, getting that double-headed arrow, if I can find that double-headed arrow somewhere in here. And I'm going to set up a relationship with, and let me just move this one over. And the single arrow should work too, it looks like, so we could go that route. I'm just going to move a couple things around. But I'm going to set up a relationship with the DIM product table. So the DIM product table has a primary key in here called product key. And I'm going to match that with our fact internet sales table and looking for its product key somewhere in here. And they're alphabetized, so I can kind of find those. So I'm going to click the product key, which is the primary key here on the DIM product table, and I'm going to drag it to the foreign key here, product key, on the fact internet sales table. And then it's going to open up a new relationship box here where I can see that the the DIM product table is up top, and you can see the product key is its primary key here. So this is the one side. And we'll talk about relationships coming up, but that's the one side. And then what we'll do is we'll see the fact internet sales table, which has the many side. So this relationship looks pretty good. Notice it's going to do a single directional cross filter here for us. It's going to make the relationship active, and we'll go ahead and save that. So we could have made a few changes if we wanted to there, but you can see the relationship now between the two tables. And you can see the cross filter there, that little arrow that lets us know that we're going to query from the one side where the dimension table is at to the many side where the fact internet sales table is at. Now I can spend a little bit more time creating relationships, but we'll talk a little bit about those going forward here in our coming up sections. The last thing I want to do is I want to highlight Get Data. We focused in on Excel, we focused in on SQL, but there's a lot of places in here too that you can get data from. As we mentioned, 190 connectors to use, and you can get certified connectors too if you don't find the ones that you see on the list here. Certified connectors down at the bottom, but you can go through this list and you can see all the different connectors we can connect to. They're alphabetized here, and then you can see too that we can go into File and into Database here. So there's a lot of options. We just have to know where is our data, and we can get connected to it through Power BI. Now there's a few more things I want to talk about, in particular related to connectors that you can use. I mentioned 190 of them, but I want to give you a little resource here that might be a little easier to kind of see what can connect to what. So here's the URL for it right here, and this will show you some of the connectors that we have for Power BI. And we have so many that we've alphabetized them. So you can click on the first one maybe and go through, and it shows you what they can connect to Dataflow-wise, Fabric, and Power BI-wise here, even Excel. So this might go a little further than what we wanted, but hopefully you can find the connector that you need to use. So you can look through the list, and there's a lot of them in here. I'm just looking at the A's, but you can see that there's a ton of them in here that you can use, and this might be a little bit better. Some of them have little links that you can do a little deeper dive on and see exactly where they fit into this whole picture with Power BI and Fabric and even Excel if you need it, and Power Apps. I'd like you to take some time right now to do the Get Data in Power BI Desktop Lab. It's designed to introduce you to the Power BI desktop and show you how to connect to data and use data preview techniques towards understanding the characteristics and quality of the data source. The lab steps and lab files are available in GitHub. Now let's do our Get Data knowledge check. Question 1. When connecting to a SQL Server database to get data, What language should you use to extract the data? Answer: T-SQL. Question 2. How many rows are sampled in a Power Query editor by default? This answer you may have seen in the lab. It should be 1,000. Question 3. What can you do to improve performance when you're getting data in Power BI? Answer: remove unnecessary columns and rows. This will help to reduce the size of your data model and make it run faster. To recap this section, we talked about connecting to data to start the extraction portion of the ETL process. Remember that there were many options for data sources in Power BI. We also talked about how to choose a storage model, with import being the preferred option, while direct query can be used for very large data sets and near real-time refreshing. Just be aware of its limitations. Lastly, we looked at some very common data errors and how to resolve them. I hope you enjoyed this section. See you in the next section.